Hello, we welcome you to today's webinar. Thank you for joining us. My colleagues and I will introduce how the ArcGIS ecosystem, a fully web-enabled GIS, can optimize hydrological models using global hydrology data in combination with local river flow data to improve flood forecasting and mitigation efforts, all using ArcGIS. As Noel said, today's webinar will be recorded and made available for future viewings. We will keep you on mute during this session, but we encourage you to drop your questions or comments in the chat at any time throughout the presentation. We will take time at the end to address your questions. We will also take time to engage with you with 2 polls to understand your interest in this field. Note that all of the examples and use cases discussed will be supplied as resources in a follow-up email so you can further enhance your knowledge on this topic. Today's webinar is the 4th in a 5-part series on applied meteorology using ArcGIS. The first 3 webinars covering visualization, analysis, data access and dissemination, and risk assessment are available for viewing. We will include the link to these recordings in the follow-up email. The 5th webinar in the series is listed here, will be on August 25th. This webinar series takes you on a journey to see how ArcGIS advances the understanding of the atmosphere to benefit science and society. We welcome you to join us on this journey. My name is Lorraine. I am the Director of Earth Sciences Solution here at Esri. I'm focused on geospatial technology for Earth Sciences application. I'm joined today by Dr. Dan Jokic, who is Esri's Water Resources Practice Manager. He has extensive background in hydrological modeling. We also have Cade Bean, an Esri solution engineer supporting our national government customers in using geospatial technology. And we're very excited today to have a special guest, Monica Stone. She is the GIS lead for the Operations Division of NOAA National Water Center. Monica has a Bachelor of Science degree from the College of William and Mary in Virginia, as well as a Master's of Science degree in Physical Geography and a GIS certificate from the University of Alabama. Monica is a core developer of the series of hydrological data services created to visualize NOAA's new national water model. She is also actively involved in developing web-based applications to host the National Water Model data services, which are used by the National Weather Service, river forecast centers, and weather forecast offices for hydrologic briefing preparation and general situation awareness. After an overview, I will turn it over to Dan, who will present an overview of the GIS tools that have been developed to support this type of application. Cade will provide a technical demo using ArcGIS, and what he'll do is he'll use the National Water Model and forecasting to conduct impact analysis for flooding events. He will discuss the use of field apps all the way to desktop tools to create a flood data stack from hand modeling to predict the potential impact of flooding of homes and road structures using a time series analysis, and then he'll conduct some situational awareness and decision support using ArcGIS dashboards. He will be followed by our special guest, Monica, who will provide an overview of the NOAA National Weather Center flood inundation mapping capabilities. She will explain the GIS infrastructure that is used for real-time operations to support the mission of the National Water Center. She will highlight the 40 data services that the National Water Center update every hour to serve out as weather services via a main viewer that was created using Esri Web App Builder combined with some custom elements to serve their customers. Then we will go to our Q&A session. Oh, pardon me. Businesses, government agencies, and individuals rely on weather information to protect lives and property and drive economic growth and support data-driven decisions. Weather extremes cause many different types of natural disasters, especially flooding and flash floods. Meteorological forces driving individual extreme weather events are increasingly understood in the context of larger regional or even global processes. Weather authorities use GIS to optimize hydrology models by incorporating global to local river information for more accurate decisions. Today, you will see how best to leverage a series of global and local apps, coding tools, and a geospatial data infrastructure to interact with big data alongside local data to give a comprehensive insight into a water ecosystem. We're now going to go to our first poll question, and then I will turn it over to Dan. So we're interested in your familiarity with ArcGIS, ArcHydro. Are you using it? Perhaps no, and you would like to learn more? Are you new to ArcHydro? Yes, you are, but you have not used it yet. You're using it on occasion, or you're using it on a regular basis. We're very much interested in understanding this. And our next speaker, Dan, who is well-versed in ArcHydro, is going to give you an overview of the tools that are relevant to today's topic. So we're seeing the poll results coming in, and now let's see. Okay, so 52% want to know, but they want to learn more. So, well, welcome. You are definitely in the right spot. You're going to be very excited about what we have on the docket today. I'm going to turn it over to Dan so he can start to highlight the ArcGIS Hydro.
Thanks, Lorraine. Good morning, everybody. Let me first set the stage for this webinar. The key idea behind flood forecast integration is development of actionable intelligence. How do we relate efforts of our water modeling community to local scale, where that modeling can be used to minimize loss of life and property? This is nothing new. The industry has been doing this since late 1970s, and there are many operational systems in the world that do that and have been doing it for many years. Traditionally, these systems were very local, very detailed and expensive to develop and maintain, and not portable. So what is new is thinking that this can be done at scale previously not possible. Can we use the existing technology and global data and models to make the entry point into this feasible for everyone? Can we build easy to access, simple to configure and maintain applications that concisely present not just information about the flows and flood extents, but actual local impact that is meaningful to local first responders and public? For example, what you see on the screen here is a dashboard that shows impact on population and critical infrastructure summarized over emergency response units and next 3 days. Or on the next dashboard, we have a detailed representation of the impacted infrastructure that is updated as you zoom into specific region. And that is what we will explore today. As Lorraine outlined, we'll start with some of the core functionality for hydroanalysis in Esri's technology that are the foundation for flood and impact analysis. In ArcMap and ArcGIS Pro with Spatial Analyst extension, there are 12 hydrology geoprocessing tools. Most of these are also available as raster functions in ArcGIS Pro. And in ArcGIS Image Server, these tools are exposed as geoprocessing services that can leverage distributed raster analytics on a cluster of machines for big data processing. I will not talk about all of these functions, but will highlight the flow distance function that is used in calculation of hand values. The tool computes vertical or horizontal distance from cells to the nearest stream cell following single or multiple flow paths. The vertical flow distance is also referred to as hand or height above nearest drainage. Hand measures the difference in elevation between a point in the landscape and the stream bottom that floods that point. Combined with flood depth at the stream, hand raster can be used to quickly determine if a structure will flood or not. This comes in handy in flood inundation mapping and is the foundation for the analysis presented later in this webinar. The core GIS capabilities, including spatial analyst functions, are integrated into ArcHydro to provide a more streamlined processing interface. The idea behind ArcHydro is to provide GIS framework for development of integrated analytical systems for water resources. It includes the data model, tools, workflows on how to best use the tools for particular use cases, and the community of users with common interests and patterns of use. The ArcHydro community page is the gateway to all ArcHydro resources and platform to share information and experiences with other users. ArcHydro started as a project to demonstrate geodatabase capabilities in water resources. It was led by Dr. David Maidment at the University of Texas and focused on the ArcHydro data model and efficient representation of water resources data structures within geodatabase environment. It was released in 2002 as a data model, a tool set, and an Esri press book. It included an initial set of 30 tools developed by my team. Since 2003, ArcHydro continued development through projects. This included extension of the data model, particularly development of groundwater component in 2007, and refinement of time series data structures. We also added over 300 tools to cover different aspects of data development and analysis. These tools were developed through project work and are a reflection of our user workflows and requirements. Esri also offers formal training classes on ArcHydro that are managed as standard Esri training but are delivered by my team. Basic ArcHydro elements are available for free through the community page. This includes the data model, tools, workflows, and documentation. Most tools are available both in ArcMap and ArcGIS Pro desktop environments. Development of new tools is now primarily done in Pro with a port back to ArcMap. For fee offerings include training and consulting, and if you're interested in those services, please contact me. ArcHydro is used extensively. We have about 1,000 downloads monthly, and we have applied ArcHydro on over 100 projects over the last 20 or so years. And something I'm particularly proud of, we trained numerous professionals through over 120 ArcHydro and H&H classes held on 4 continents. When you install ArcHydro tools, you get a toolbar and a tool set with over 200 tools. You will most likely never use all of them, probably 20 to 30 tools that are specific to your needs. ArcHydro has different grouping of tools, so depending on who you are and what you do, you will use a different set of available tools. Most everybody is going to use the tools that deal with terrain processing and for unique identifier management. Once you're done with terrain pre-processing, then you can do different things. Watershed delineation is often the next step, followed by watershed characterization. ArcHydro has a whole suite of tools for floodplain delineation, including the hand methodology. Hand approach has been around for a while and popularized through the National Flood Interoperability Experiment, or NIFI for short. Can you advance the slide, Lauren, please? Thanks. Hand surface basically normalizes the water surface elevation with respect to the slope of the river, thus making flood computations faster. Hand can be calculated using any resolution of the data, either using national or local high-resolution data. Use of hand technique is based on the assumption that for a given reach, depth of flooding is constant. The flooding at the cell in the landscape contributing to reach then happens when hand value of the cell is less than the flood depth in that reach. Regionally, each reach can have different depth of flooding, and that depth can vary with time. The hand processing capabilities are captured within the hand processing toolset in ArcGIS. Besides those tools, we have tools for integration with the national water model, so you can string together the full workflow, starting from the raw topography and hydrography to forecast model integration and impact assessment. And with that, I'll transfer it to Cade, who will show some of these tools and workflows in action. Cade?
Thank you so much, Dan. Appreciate it. So today we're going to examine a few approaches to viewing and modeling flood data, and we'll start by talking about a web application designed for emergency response. Then we'll dive a bit deeper into how that was constructed. Next, we'll add in a forecasting component using the National Water Model. And then finally, we'll tie it all together by looking at a decision support and situational awareness tool. So let's start with Pin to Flood. Pin to Flood is a web-based application that was built in collaboration with the University of Texas at Austin, which allows an on-scene first responder to make their own flood maps on demand. It allows responders to quickly communicate the extent of flooding within their emergency operations center for quick management of response. So here we're looking at the Lower Onion Creek area just south of Austin, Texas. And in the field, a responder can use this mobile application to drop a point to examine the flooding extent for the particular reach that they are closest to. So for example, if the first responder is standing here right at the intersection of these two roads and they see that the flooding has reached this area, they can drop a pin here. And as they drop a pin, we'll go ahead and save that. And what it's doing in the back end is it's pinging any of the flood stack that is underneath this area. So that way there's a quick response for when they drop that pin. It's going to show the extent of flooding around this area. So as soon as this finishes up, we'll see a polygon that shows the extent of the flood around this particular area here. Give that just another moment to pop up. So as this is happening, we'll navigate over to the EOC, or the Emergency Operations Center, and you'll see right away that the pin that we just dropped over in the mobile app has already been dropped in the Emergency Operations Center piece. So it looks like we still have some processing that's happening over here. Let's just give this a quick refresh and we'll try that again. All right, so in this case, typically what we'll see happen once that finishes processing is we'll have a polygon that shows the extent of that flooding in the area. So this would allow an emergency operations center dispatcher to more efficiently distribute additional field responders out into the field. So with that, let's go ahead and see how we kind of built this behind the scenes using ArcGIS Pro. So here we're going to examine the flooding extent based on a particular height above nearest drainage or hand, as Dan mentioned earlier, and its impact on roads and buildings. We're then going to leverage data from the National Water Model to create a time series forecast of flooding that can be used for decision support. So first here we have our catchment that will define our processing extent. And as we saw with that Pin to Flood application, we're looking at the northeast portion of the Onion Creek, Colorado River watershed near Austin, Texas. So in order to examine the impact, I've brought in a couple of different layers here. And we'll see these black lines as well as these dots. Those are going to represent both the street center lines as well as building footprint center points. And so using the Texas Natural Resource Information Systems Open Data Site, we've pulled in those building footprints. And we've also leveraged the Living Atlas, which is Esri's collection of authoritative and curated data sets to bring in these road center lines that we're looking at. So we've clipped those to our area of interest in this case, which is going to be our catchment. These will be used in future steps to calculate the impact of flooding. So for this project, in the interest of time, we've done a little bit of pre-processing. We've already generated some model reaches, as well as a hand raster layer. So if we turn on our hand layer, we'll see that we have essentially what amounts to a DEM that has hand values associated with these modeled reaches that you see here. Now, this is a pretty detailed raster. This is a 1 by 1 meter resolution raster. And we're going to use this to do some additional analysis here. So for this here, our next step really is to create a flood stack. And then this can be used to, as we saw with that pin to flood app, we can see the different flood extents for different polygons based on that hand value. So in order to create some of these outputs, we're going to use some tools in the ArcHydro toolbox. So if we go to our geoprocessing pane, navigate over to toolboxes, we'll see we have these ArcHydro tools. Within there, we have our H&H modeling and hand processing. So the tool that we're going to use here is create a flood data stack from hand. So we're just going to navigate to a folder where we want to store the output. We're going to input our modeled reaches here, and we'll also input our catchment feature class. Next, we'll input our hand raster that we just discussed, and we'll go ahead and run this. And so when we run this, by default, we'll see 50 different steps of depth that are going to be processed. And depending on the resolution of your hand raster, this could take quite some time. So in the interest of time, I've already run this. So let's take a look at some of the outputs that we're going to be using today. The first of which we'll see here is the FP zone. And this FP zone represents the flood polygon for each flood depth slice. And this one is actually going to be cumulative across all reaches. Here we'll see that we have the shape of the particular polygon. We have an H value, which is going to be the height above nearest drainage. And we also have an H index that's associated with that. As you see, our H value increases by 0.3048 meters or 1 foot at each step. And so with our processing here, in our case, we ran with a few more steps than the default of 50. We ran this with 86 individual steps because we had the detail. Next, we're going to look at our FP zone river. This is going to be a lot of the same. However, we have a composite ID and a feature ID, and these are going to be associated with those modeled reaches. So this is going to give us a little bit finer grained control over the analysis that we're going to be looking at. Finally, I want to show you the PF model stream table. We'll be using this in a future step. This provides stream characteristics in a table as a rating curve. We have a river ID that ties back to a stream ID in the FP zone river feature class that we just looked at. We also have a hydro ID and an FP river that ties into the FP river feature class. Finally, it contains a Q value, which is going to represent the discharge for a reach that we'll be using in a later step for forecasting. So with those 3 tables, we'll go ahead and turn off our hand value. And now that we have our results, we'll need to create a preliminary layer using the Summarize Within tool that's going to contain our impact metrics. So if you recall, we have 2 different layers that we're looking at, both the street center lines and the building points. So what we've done is use the Summarize Within tool to create a count of lines and a count of points that are going to intersect with our zone river polygons. So this looks very similar to that FP zone river attribute table that we saw. However, we also see a count of lines, the length of those lines in kilometers, and then we also see a count of points. So this is going to represent the number of buildings in a flood slice, as well as the number of road center lines within that flood slice. So keep this in mind. We're going to be using this in our final output a little bit later. So I want to show you the output here of our FP zone river. So in order to do that, we're going to zoom into Moore's Crossing. We'll go ahead and turn on this FP zone river feature class here. And here you'll see it looks like we just have 1 polygon. However, if we click this area using the Identify tool, you can see that we have a stack of polygons here. So each stack is going to be tied to an H index that has an associated height value in meters. And as we move across, you'll see that these polygons are going to start to, if we start at the top here, these polygons are going to start to get a little bit bigger as that height index increases, that H value is going to increase along with it. So within this feature class, we have all of these flood slices that we can use. Now, this is excellent, but all we're really doing here is seeing the flooding potential at a particular location. We can't really see much more than that. So what we're going to need to do is we're going to need to bring in the national water model to do a little bit of forecasting. And in order to do this, we're going to download that current flow forecast. We're going to convert flows at modeling reaches to stages. We're going to assign those forecast flows to modeling streams. And then we're going to go ahead and map the flood extents. So the first thing that we're going to do is we're going to take advantage of another tool in the ArcHydro toolbox. In this case, we're going to use the download national water model Q values from an Esri URL. So if we load this up, all we're going to do is input our modeled reaches. We'll input feature ID for those modeled reaches as our COM ID field. And we're going to go ahead and check this value to update the feature ID with one-to-many hydro ID fields. And so this will allow us to see the forecast across a number of different time steps. So the output of this is going to be called TSNWM_SR for short range. And again, to save us a little bit of time, I've run this for us. So this is the result of the tool. You'll see that we have a time step in 18 step increments here, starting, we've run this in the past on June 11th. And we have a height index value, and we have, again, that height above nearest drainage. Now, typically when you run this tool the first time, you don't see this Q value. So what we're actually gonna do, we won't see this H value. We bring in that Q value right away from running the tool, but we'll actually need to interpolate this H value. So typically this wouldn't be here. So what we'll need to do is we'll need to run a third tool, which is called Interpolate from lookup table. And this tool is going to bring in, it's going to interpolate the height above nearest drainage value from that Q value that we just pulled out of the national water model. So our source table in this case is going to be the NWM short range table we just looked at. Our lookup table is going to be the PF model stream that contains those Q to H values. We're going to specify our Q field, specify our height field, as well as some items here to properly join the data. So when we run this, we're going to get a feature class that contains a number of steps that has an associated and interpolated height above nearest drainage value that is related to the discharge for a particular reach. So let's examine that output. Here we have the flood extent time step tool. We'll see that we have some very similar features that we've seen before. We have our feature ID for each individual reach. Now we have a TS time field, which is going to represent a timestamp that has an associated discharge value, as well as a height above nearest drainage value. So now we have brought in that temporal component to our data set. So we can actually visualize this and see the impact that flooding might have at a particular time based on that national water model. So if you'll recall, we had this layer that has all of our buildings and roads that are associated with flood slices. We're simply going to join that to our flood extent time step data. So let's examine that final output here. If we enable time on this layer, we can actually zoom into an area like Bluff Springs, for example, and across that national water model time step, we can see the changes in that flooding extent. So if we play this across for each hour, we'll see these polygons are dynamically changing based on that national water model forecast. So you'll see here with some ArcGIS Pro layer blending tools, we can very quickly see that we have some areas around here where we're gonna see some flood inundation that's impacting some of these buildings. We click this polygon at this reach, we can see that we have 4 individual roads that are gonna be impacted that have 0.075 kilometers of road affected. And we also have a count of points associated as well. We'll see that we have 1 building in this area based on our impact layers. If we zoom back over into Moore's Crossing, you can see this a little bit better. So while it's not impacting as many buildings in this area, we can see that extent changes pretty heavily based on that national water model forecast. We'll see here, we'll get a little bit of extra flooding right down here in the corner. So with all of that, we've used ArcGIS Pro and the ArcHydro tools to create a flood stack and tied it into the national water model to get an interpolated height above nearest drainage based on that national water model forecast. So now that we've completed our analysis, we can actually create something like a situational awareness or a decision support tool. And for that here, we have a dashboard for the Rhode Island Department of Transportation. And you'll see here that we've used very similar data that we just looked at within ArcGIS Pro. We have a number of buildings, we have road segments, and we have bridges that are going to be affected by flooding. So if we zoom into this area around Newport, you'll see that the values are going to dynamically change in the upper right-hand corner. So in this current extent, we have 15 buildings, 11 segments, and 4 bridges that could potentially be affected by flooding. Furthermore, we can click a bridge ID to see a particular bridge that is going to be affected in this area. So with ArcGIS Pro, you can take full advantage of ArcHydro tools to conduct impact analysis based on forecasts with the National Water Model. With those results, you can then create meaningful visualization and communication tools in ArcGIS dashboard to help make informed decisions to support the protection and livelihood of your communities. Thanks so much. With that, I'm going to pass it back to Lorraine to conduct our final poll.
Thanks so much, Cade. So we're interested in understanding the workflows that you're interested in. Are you incorporating big data alongside local data? Are you looking to improve global hydrological models with local data? Are you trying to resample or downscale big data so that you can perform analysis? Are you looking to conduct monitoring with dashboards or easily access data services? So we'll give the poll a few more minutes. I want to give everybody the opportunity to be able to select something. We're getting quite a mix. So we can see the winner was improving global hydrological models with local data. And that's what we were talking about earlier. And so we have some additional resources on that topic, as well as downscaling. I mean, each of these topics, we will have additional resources for you to learn a bit more, and these resources will come to you in a follow-up email. So with that, we're now going to turn it over to Monica, who we're very excited to have here today.
All right, can you see my screen?
Yes, we can.
All right.
You're not in slide mode though. There we go.
All right, well, good morning. I'm going to be speaking a little bit about some of the GIS development and activities that are ongoing at the National Water Center. My name is Monica Stone. I am the GIS Specialist Lead within the Operations Division of the National Water Center. And the National Water Center is part of the National Weather Service, which is part of the National Oceanic and Atmospheric Administration. Our vision at the National Water Center is a water-ready nation. So we are addressing the nation's challenges when it comes to water extremes, water scarcity, and water quality. And part of our mission is to develop and deliver state-of-the-science hydrologic data and data services to help our stakeholders make quick, informed hydrologic decisions. We do everything from flooding to droughts, water availability, and water quality. So anything related to water is under our domain, and we do this across all timescales. In August of 2016, we released the National Water Model. And over here on the right is an animation of the water model output for the 2020 water year. The National Water Model is a hydraulic modeling framework, and it provides both observed and forecast stream flow for about 3.4 million waterway miles across the continental United States, Hawaii, and also Puerto Rico. This new guidance complements the approximately 4,000 official river forecast locations across the Weather Service, and those are gauged locations. So the real value of the National Water Model is it helps us provide valuable hydrologic information to areas that previously had none. In total, we generate about 1 terabyte of data daily from the National Water Model. So with so much data coming out of this new model, we needed a way to be able to quickly synthesize and post-process it and be able to visualize it so that our stakeholders, again, could be able to look at it and easily make quick, informed hydrologic decisions. So in order to do that, we have published a series of about 40 data services, and these are published on our enterprise GIS system that we host at the National Water Center. As you can see, all the services are listed on the screen, and they kind of fall into 3 temporal categories. The first category, our analysis category, those are services showing current hydrologic conditions. We also have a short range set of services that look out the next 18 hours for the continental United States and out the next 48 hours for Hawaii and Puerto Rico. And then lastly, we have some services for the medium range, and those look out over the next 10 days and are currently only available for the continental United States. Across all 3 temporal configurations, we do update these data services in real time as new data is available from the National Water Model. So in the case of the analysis and short range services, that happens every hour. With our medium range services, that happens every 6 hours or about 4 times a day. As you're scanning through the list of different products, you'll notice they kind of fall into several different categories. We have services that show observed and forecast stream flow. We have a lot of services that focus on high flow events, so what magnitude of the high flow is expected, when it's expected to peak, when it's expected to recede. We also have a similar subset of low flow services. We have services that look at soil conditions, snow conditions, observed and forecast precipitation. And of greatest interest, I think we have a subset of services that focus on inundation mapping. And I'll speak a little bit more on the inundation mapping side here in a moment. You can view some of our data services on our public website, which is water.noaa.gov. Not all of them are available there yet, but we are continuously adding new products and services to our website, so stay tuned for that. You can use the interactive map viewer to click around on the different layers. You can click reaches and see hydrographs of National Water Model output, as well as download images if you'd like to save off a particular service. Internally, I mentioned that we have an enterprise GIS system at the National Water Center. We use the portal in that system to serve out our data services to the National Weather Service forecasters across the nation, as well as associated web maps and web applications that we have developed for operational use. So I mentioned that one of the big things that we're working on at the National Water Center is doing real-time inundation mapping. So previous speakers in this webinar series have mentioned the height above the nearest drainage method for mapping inundation extent. That's the same methodology that we are using at the National Water Center. We're using it to compute flood libraries for the entire nation. We have 2 flavors of inundation mapping that we're doing. The first one utilizes the analysis and forecast stream flow output from the National Water Model. With this version, we provide a look at current inundation extent as well as 18-hour, 3, 5, and 10-day maximum extents. Currently, we're running that in real time for portions of the eastern and southern regions of the U.S., but we have plans over the next year to expand this out to the entire continental United States. The second type of inundation mapping that we are focusing on at the National Water Center is termed replace and route. We only provide a 5-day max extent for that. And the big difference here with this one is that instead of using the National Water Model stream flow guidance, we are using the official forecast from those approximately 4,000 locations I mentioned that are gauged locations for the National Weather Service. So this is available across the entire continental United States currently, but only downstream of gauged locations. And so the real utility of the National Water Model is that it helps provide us not only stream flow, but inundation mapping estimates for areas where we do not have any current hydrologic information. And over here on the right, I have an animation of inundation extent produced by the National Water Model back in 2018 during Hurricane Florence. And so what you're seeing is the red shaded areas. That's the FEMA 100-year floodplain. And as the animation moves through time, you'll see the blue polygons expand. That's the National Water Model inundation extent. Then you'll see as we continue through the event, it begins to recede. So this is some of the type of information that we're working on developing and providing to stakeholders at the National Water Center. So in addition to providing those real-time data services, we also do utilize web maps and custom web applications within our operational workflows as well. And so what I'm going to do now is exit a PowerPoint and do a little demonstration of one of our custom web mapping applications. So what you're seeing right now is our water view dashboard. We call it water view because it's a one-stop shop for all water services coming out of the National Water Center that show National Water Model data. So this is used by our forecasters for operational, in their operational workflows for situational awareness. So you can see the core of the dashboard is a map viewer, lots of widgets that the forecasters can use to interact with the data services. I mentioned before that all the data services are live and updated in real time. So if I click on a feature, I can get more specific information about that location, and you'll see this service was updated just a few hours ago. So in it, over here, you can see we have lots of stacked layer lists with all of our data services that our forecasters can click through. And as an example of some of the customization that we've done using our Esri portal, we've created our own print widget. So a forecaster can zoom into their area of interest, turn on their desired layers, and use the dialog down here to create a graphic. And so here's an example of what a graphic might look like once exported. And these graphics are nice because we are able to, on our portal, customize them to include our agency's logos and the appropriate disclaimers that need to go with each product. These are used by our forecasters to provide situational awareness briefings for emergency managers and other decision makers when responding to hydrologic events. Lastly, I just wanted to mention that we do have a YouTube account, so please check it out. And if you'd like, you can subscribe and follow and see some of the content that we publish from the National Water Model. We publish outputs usually of major events, but we also have a lot of training material there if you're interested in learning more about the water model or some of the data services that we provide. And so I just want to thank you all for letting me have the opportunity to speak with you today, and I will turn things back over to Lorraine.
Thank you so much. Let's see. It was such a great presentation. We will shortly open it up to questions from the audience, so please take the opportunity to type in your questions, and we'll get to those during this session. So Monica, Dan, and Cade are available, as well as myself, to answer your questions. I just want to make a few comments about some of the resources and links that Monica, Cade, and Dan spoke about. They will be available to all of you. We'll be sending those to you in a follow-up email that will, I believe Noelle said, will go out tomorrow. And then also we have this email address, science@esri.com. We welcome your feedback. If there was anything that was presented today that you have more questions about, feel free to drop us an email and we will get back to you. And so let's see now, we'll go over to questions. One of the questions that's come in, this will be directed to Monica. Is it possible for anybody to access the WaterView app, or is it just internally?
Yeah, thank you so much for the question. So the specific WaterView app is just internal to our operational staff. However, you can access a lot of the content that's there on our public website. And look for some big changes coming to our public website over the next year, because we do plan to roll out a lot of new data services.
Okay, great. Thank you so much. Another question coming also for Monica. Do you use this tool? I'm not sure which one they're speaking about, but do you use this tool for pollution modeling and pollutant concentration prediction and mitigation results?
Hey, thanks again for the great question. Currently, we are not doing any pollution modeling at the National Water Center, but it's something that we may explore in the future as we expand our water quality program.
Okay, great. Thank you. Another question coming in about training and the ability to learn ArcHydro and the flow that Cade went through. Are there opportunities for us to learn more about this? And I'm going to turn that one over to Dan.
Yeah, yes. So the whole workflow for both development or terrain processing that has to happen, and the flood slicing that Cade showed, that is covered between our ArcHydro training class and H&H training classes that are offered through Esri Ed Services. Just a word of warning, we are moving these classes to be completely pro-based. So we are going to have them available for general enrollment in this coming fall. So Q4, probably sometime in October, and they will be announced through our regular training sites. If this is something you want to learn right away, just give me a call and we'll work with you. We have something that's it's called initial operating capabilities package that we can provide, where we work with your data and we do tech transfer specifically in this domain. So it just depends on how much you want to learn in what general area, but definitely just reach out to me and we'll find the best way to help you.
Okay, great, Dan. And then also I wanted to comment on another resource that will be available in tomorrow's email is a series of ArcHydro webinars, additional ones, where Dan and team are going into a bit more detail. Can you comment on that for a second, Dan?
Yeah, so for those of you who really want to dig into ArcHydro, we did a 4 webinar series earlier this year between February and April that deal with general ArcHydro capabilities, and then more into flood forecasting and modeling, and then hydrology, and then H&H modeling support. So those are all available, and the links will be provided in the follow-up. And so please go and have a look, you know, so that's going to be available to you.
Great. And then we had a question about webinar recording. Could we provide it? And yes, again, this is being recorded, and the link to the recording will be available tomorrow in the resource email. Okay, so we have a question. I guess the whole team could answer this one. Is this type of real-time inundation mapping applied in other countries?
Yeah, so let me answer that. Yes, that this methodology, when we were putting together the infrastructure for it, really has 3 key components. One is the flow forecasting. In a case that we discussed here, we were talking about using the National Water Model, which is in US. but there are global models, and we have built within ArcHydro tools the interfaces to the European Center for Mid-Range Forecast, ECMWF, and you can use their forecasts to forecast this on basically global scale. There are about 1 million reaches that they're doing forecasts on. So yes, this whole methodology can be applied to pretty much anywhere in the world.
Thank you. And also in the resources, we'll have links to data sets within the Living Atlas of the World that can provide additional global information. We have another question from Monica. Let's see. They're curious to know if the inundation mapping procedures, in your inundation mapping procedures at the Water Center, are you incorporating depth rasters as part of the inundation modeling?
Are they referring to like bathymetry? Sure.
Yeah, I'm not positive. My guess, I'm going to guess, maybe the person could type a little more info, but I'm going to guess that I'm thinking they're talking about the, oh, yes, sorry. They are referring to bathymetry.
Okay, yeah, that's what I thought. So we are incorporating it where we have it available, but as you can imagine, you know, I mentioned we have 3.4 million waterway miles, so we don't have bathymetry for every stream reach in the country. So that's something that we're working on, getting some better ways to estimate that where we don't have it. So the answer is sort of yes, and we're going to be improving it as we go along.
Okay, the reply is awesome, and thank you. Let's see, so we now have a question about, are there plans to expand ArcGIS Hydro tools to include the capability to model ponding water in flat terrain like Houston? Also, does the National Water Model account for storm surge along the coast during tropical storms? So that's two questions.
So I can take the first one. The simple answer to that is yes, and we are actually doing that in the lake areas. So in our flood slicing methodology, there is a technique to go and isolate the call it a flat or horizontal surfaces areas like in the lakes. We're making assumption that it's horizontal as opposed to sloped, and that is possible to do. Your forecasting then for that specific area has to be a little different because you are now, flow is really not the forecaster of your stage, so you have to handle that separately, but it is possible to handle that.
Okay, thanks, Dan. And then Monica,
yeah,
the question.
Yeah. So the question was about storm surge in the National Water Model. So in the current operational version of the National Water Model, we do not incorporate storm surge. However, we are in the process right now of adding storm surge, and we're all coastal processes, so you know, tidal influences as well, not just storm surge, into the National Water Model. So that, you know, that process is underway, and hopefully will be put into operations in the next couple of years.
Okay, great, thank you. We have another ArcHydro question. Can we use ArcHydro to monitor the contaminant of an aquifer by a pollutant?
Yeah, so you really don't need ArcHydro for that, right? You need a monitoring system for that, where you know, you're doing a water quality monitoring at a specific location. Once you have that monitoring in place, you're really creating a time series of a specific constituent at a given location, and then you can use some of the ArcHydro tools. There is a specific ArcHydro for groundwater tool set that was developed by our partner Aquaveo. That includes also integration with ModFlow if you want to do full-blown groundwater modeling. So yes, if you have the information about the water quality at specific groundwater locations, then you can mobilize that within ArcGIS.
Okay, great. Thanks, Dan. And then this question would go to both Cade and Monica. It's about situational awareness dashboards. Once you have your analysis created and data feeds, how hard is it to create those dashboards? Do you need to be able to code, and is there additional help to help us get started?
I can take that one, Lorraine. The way that ArcGIS dashboards are designed is that they are completely configurable off the shelf. There is no coding required to create a dashboard like the one that I demonstrated today. If you want to get a little deeper into it, we do offer the ability to do a bit of coding in Arcade, which is the pervasive expression language native to ArcGIS. So there's a lot of deeper things that you can do in regards to how you want to symbolize different pieces, based on if-then statements, if that's the route that you want to go. But really, to create something like I demonstrated with ArcGIS dashboards, it's pretty much a drag and drop operation in selecting the type of data. We have some pretty extensive documentation for that, and we can send that across to Lorraine to include in the resources for this webinar.
Great. And what about you, Monica? Because you showed some dashboards as well. Could you comment?
Yeah, sure. So I would say the majority of things that we do in terms of dashboards and web application development is out of the box. So it's just what's available with the Esri software. You don't necessarily need to know coding to set up a lot of it. I do like the ability to add some custom features, and we have done that in a number of cases. But in all cases, we just utilize documentation off of Esri's website. There are a lot of cool custom tools that you can configure in your portal or on online web maps, but there's great instructions, kind of how-tos on Esri's website, and we've utilized those. For example, that print widget that I demonstrated, we just followed the instructions off the website, and we were able to custom configure and set that up. So yeah, I hope that helps answer.
Yeah, that's great. Okay, so it looks like we're rounding out all of the questions now. I want to thank everybody's time for spending time with us today to learn more. And again, you will receive an email tomorrow with a whole host of resources, all ranging from blogs, from documentation, learn lessons, and workflows to help you get up to speed on this topic. So thank you very much for joining us. We hope you found today informative. Again, feel free to reach out to us at this email at any time and we'll respond. And so this now concludes our broadcast, and we hope that, or before we conclude, we hope that we do see you at our next webinar coming up in August. Thank you so much for your time.